If you look back at how enterprise networks were designed 20 years ago, the model was simple. You had a strong external firewall, an internal trusted network, VPN access for remote users, clear separation between inside and outside. That model worked when applications lived in data centers, users sat inside offices, and infrastructure was predictable. But today, your enterprise likely operates in hybrid environments, multi-cloud architectures, remote workforce models, SaaS ecosystems, API-driven integrations. The perimeter has dissolved. The network is no longer a castle with thick walls. It is a distributed mesh of connectivity across identities, workloads, APIs, and cloud environments. As an enterprise security architect, you must move from perimeter-based thinking to segmentation-based thinking. Network security architecture is no longer about blocking the outside world. It is about controlling movement everywhere. One of the most important architectural principles you must embrace is layered defense. Layered defense means you do not rely on a single control to protect your environment. Instead, you design multiple defensive layers. Edge protection, identity-based controls, network segmentation, application level validation, endpoint security, logging and monitoring. If one layer fails, others continue to provide protection. For example, if a phishing attack compromises user credentials, identity-based controls may limit privilege escalation. If privilege escalation occurs, segmentation limits lateral movement. If lateral movement is attempted, monitoring detects abnormal traffic. Layered defense assumes failure. Architecturally, you must design controls that overlap intelligently. This does not mean adding redundant tools. It means ensuring that each layer addresses a different risk dimension. Depth creates resilience. In traditional networks, once inside the perimeter, systems often trusted each other implicitly. Flat networks were common. The risk of flat networks is simple. If one system is compromised, attackers can move laterally with minimal resistance. Modern network security architecture requires micro-segmentation. Micro-segmentation means dividing the network into smaller logical zones where communication is explicitly controlled. Instead of broad internal trust, you define which application can talk to which database, which service can communicate with which API, which administrative subnet can access which management interface. Micro-segmentation reduces blast radius. Even if an attacker gains initial access, movement becomes constrained. You must think of segmentation not only in physical networks but also in virtual networks, cloud subnets, Kubernetes clusters, API gateways, service meshes. Segmentation is no longer a network-only concept. It is an architectural control. Hybrid environments introduce complexity. You may have on-premises data centers, cloud platforms, SaaS applications, third-party integrations. Secure connectivity must be designed deliberately. Common connectivity models include site-to-site connectivity, secure remote access, private cloud interconnects, partner connectivity gateways. Your architecture must define trust boundaries, traffic flow policies, encryption standards, monitoring integration. Connectivity should not be ad hoc. For example, if you connect on-prem systems to cloud environments without segmentation and inspection, you extend internal trust boundaries into the cloud. Secure connectivity requires encryption in transit, explicit routing policies, segmented connectivity zones, logging of cross-boundary traffic. Connectivity is an extension of your security posture. It must be governed architecturally. In cloud environments, many services can be exposed publicly by default. Public exposure increases risk surface. Private endpoint architecture allows you to access cloud services through private network paths instead of public internet endpoints. This reduces internet exposure, attack surface, unauthorized external probing. As an architect, you must evaluate which services require public access, which services should remain private, how internal routing integrates with cloud private services, how DNS resolution supports private endpoints. Private connectivity does not eliminate all risk, but it reduces unnecessary exposure. Exposure minimization is a key architectural objective. The more you reduce unnecessary public surface area, the smaller your attack surface becomes. Traditional network security focused heavily on north-south traffic entering and leaving the network. Modern threats exploit east-west movement, traffic between internal systems. Once inside, attackers attempt to move laterally. If you do not monitor and inspect east-west traffic, you may not detect this movement. East-west inspection includes internal firewall controls, network traffic analysis, behavioral monitoring, application layer validation. You must design internal visibility. For example, if an application server suddenly attempts to connect to a financial database it has never accessed before, that should trigger inspection and potentially intervention. Visibility is critical. Segmentation without visibility creates blind zones. Visibility without segmentation creates exposure. Architectural maturity integrates both. Firewalls remain essential, but their role has evolved. Modern firewall strategy must consider application layer inspection, identity-aware policies, threat intelligence integration, cloud-native firewall capabilities, centralized policy governance. Instead of static IP-based rules, modern policies may include user identity context, application recognition, risk-based blocking, encrypted traffic inspection where appropriate. In cloud environments, firewall strategy may extend into virtual network firewalls, security groups, network access control lists, web application firewalls. The objective is not to deploy more firewalls. The objective is to enforce consistent policy across environments. Firewall governance must prevent rule sprawl and unmanaged exceptions. As an architect, you must define standard firewall patterns, approval workflows for changes, logging integration, policy lifecycle management. Firewalls are no longer perimeter gates. They are enforcement points within a segmented ecosystem. Network security architecture does not operate in isolation. It must align with identity-centric architecture, cloud security architecture, zero trust principles. For example, network segmentation should align with identity roles. Conditional access should integrate with network access decisions. Cloud routing should enforce least privileged service communication. When identity, network, and cloud controls operate cohesively, architecture becomes strong. When they operate independently, inconsistencies emerge. As an enterprise security architect, your responsibility is integration. You must design the network as part of a broader security ecosystem. Network architecture plays a critical role in incident containment. If ransomware enters one segment, segmentation can prevent spread. If a cloud workload is compromised, network isolation can contain impact. Resilience-focused network design includes segmentation boundaries, automated isolation capabilities, incident response integration, centralized logging, failover strategies. Network architecture must support recovery as well as prevention. Containment speed often determines business impact severity. Architectural decisions made today define tomorrow's incident outcome. One of the risks in modern network security architecture is overcomplexity. Too many overlapping controls can create operational confusion, policy conflicts, visibility gaps, administrative overhead. Architectural discipline requires simplification. Define clear zones, define consistent patterns, automate policy enforcement, avoid unnecessary custom rules. Complexity increases error probability increases risk. Simplicity, when architected thoughtfully, strengthens security. Ask yourself, is your network still designed around a single perimeter? Do you have visibility into east-west traffic? Are segmentation policies explicit or assumed? Is cloud connectivity governed architecturally? Are private endpoints used strategically? Is your firewall strategy modern and identity aware? Network security architecture must evolve with enterprise architecture, from perimeter to segmentation, from static trust to contextual enforcement, from implicit movement to explicit policy. When designed well, your network becomes a containment system. When designed poorly, it becomes a highway for attackers. If this lecture helped you rethink network security architecture beyond the traditional perimeter, make sure you subscribe to this series. In the next lecture, you will explore application and DevSecOps security architecture and how secure software delivery integrates into enterprise design. Like this video if you found it valuable. Comment below and tell me, is your organization still perimeter centric or moving toward true micro-segmentation? Your journey toward mastering enterprise security architecture continues in the next session.